So we're doing section 4.4, number 36, and the question reads, find the volume of the largest right circular cone that could be inscribed in a sphere of radius 3. And this is the diagram right here. Here's the sphere and the cone. And the volume of a cone is 1/3 pi r squared h. So you use that equation. You plug in the radius and the height. We're going to do it in terms of y, so you can't use x. So you do the Pythagorean theorem, which is x squared plus y squared equals 3 squared, which is the radius. And you solve for x. You plug that in for the radius, and then the height is 3 plus y. And then after that, you take the derivative using the product rule, and you get dv dt equals 1/3 times pi times negative 2y times the quantity 3 plus y plus the quantity 3 squared minus y squared times 1. And when you simplify that, you get 1/3 pi equals negative 3y squared minus 6y plus 9. Then when you multiply by 1/3, you get pi times negative y squared minus 2y plus 3. And you set that equal to 0 so you could find the maximum. And you know that pi can't equal 0, so you ignore that. So you set this quantity equal to 0. And when you factor that, you get negative y plus 1 times y plus 3. Which then you get y equals 1 and y equals negative 3. You chart this on a derivative line, and you test each point. And when you test it between negative 3 and 1, you try 0, you plug it into this equation, and it ends up being positive. And then here it's negative when you plug in 2. And when the derivative goes from positive to negative, that means it's a maximum. So you have a maximum at 1. And then to find out what the maximum is, you have to plug it back into the original equation. And when you do that and solve it, you get 32 pi over 3, which is the maximum volume.